All right, good afternoon, Applied Geometry. So today's lesson is about the slope of parallel and perpendicular lines. You might have heard of this before, and so this might be a nice little refresher. There'll be plenty of practice to make sure that you have mastered this target. So please make sure by the end of today that you are getting to the point where you can write the equation of a parallel and perpendicular line. Now, to be fair, we're not going to get all the way to the equation part of it, but an important part of writing the equation is knowing the slope of the parallel and perpendicular lines. Okay, so please make sure you can find the slope of a parallel or a perpendicular line by the end of this lesson. Okay, all right, just some quick housekeeping real quick. Okay, if you have homework from last night that is completed, and then fifth hour, your bell work, if you could turn both of those things into my turn-in box, that would be fabulous. Okay, all right, onwards. So this might look somewhat familiar from Algebra 1. Okay, so these are equations of lines. We know that they represent a line on the coordinate plane, and that we can plug multiple points into these lines and have it come out, and that's how we know the points that are on of these lines. Okay, now these lines are written in slope-intercept form, which you might find familiar with this being the slope and this being the y-intercept. Okay. So, looking at these two equations together, okay, notice that both of them have the same slope. Okay, that is very interesting, okay, because if they have the same slope, something interesting might happen. Let me go ahead and graph these two equations. So remember, when you graph one, you start with the y-intercept, so it starts up here at 1, and then the slope means rise over run, so that's 2 over 1. So I'm going to go up 2 over 1, up 2 over 1 like that. And I cannot really draw a straight line, so allow me to use some tools here. There we go. Nice. So that is an equation of the line between those two. Okay. And then let me graph the other one too. So the other one, it starts at -5. So 1, 2, 3, 4, 5. And then has the same slope, so it goes up 2 over 1, up 2 over 1. Okay. And then if I draw a line through those two, it'll look something like that. And I do need to speed it up just a bit. There we go. Okay. So looking at these two lines, what do you notice about them? Very good. You should have noticed that they are indeed parallel to each other. And it kind of makes sense, because if you think about it, slope determines the angle at which the line's going to go. So if two equations or two lines are going at the same angle, then they should be parallel to each other. Okay. If I were to graph these ones, we would notice the same thing, that these ones are parallel to each other because they have the same slope. Okay. So lines that have the same slope are parallel to each other. Take a look at these equations. Notice that these ones are different. Okay, so if I take a look at these ones' slopes, they are different slopes. Okay, just being different doesn't really mean much, but these ones are pretty special in their differences. Let me go ahead and graph these two so you can see what's happening. So this one starts at +3, and then the slope is 2 over 1, so up 2 over 1, up 2 over 1, so the line is going to look like this. Okay. And then the other one is at -2. I need to start at. And then I need to go left 1 and then up 2. Or I guess, how do I want to do that? So rise over 1. So down 1, I'm sorry, over 2. Down 1, over 2. There it is. So if I draw this one, which requires some skill here. Hold on. My line got a little crooked there, but it'll work for right now. Okay. Go ahead and turn your head to the side. Look at this angle here. Okay. You might notice it looks very close to a 90-degree angle, and in fact it is. Okay. If I were to actually draw these lines nice and straight, you would see that these meet at exactly a right angle, which means that they are perpendicular. Okay. So what is special about these slopes that makes them perpendicular? Well, compare these two slopes and then compare these two slopes. You'll notice that these all have the same number in them. So this one has a 2, and this one has a 2, this one has a 3, and this one has a 3. Notice they are opposite signs. This one's positive and this one's negative. This one's positive and this one's negative. Okay. And notice that one is the flipped version of the other one. Okay, so if this one's 3 over 1, this one's 1 over 3. This one's 2 over 1, this one's 1 over 2. Okay, so we call that the opposite reciprocal whenever they're the opposite signs and then they're the flipped version of each other. And that's going to make them perpendicular. Okay, so just to summarize, we know that lines are parallel if they have the same slope. Okay, we know that they are perpendicular if they are opposite reciprocals. Okay, and this might be a good thing to have written down somewhere. Okay, so an example of an opposite reciprocal is like, 2 would become negative 1 over 2. Because 2, when you flip it over, is 1 over 2. 2 is positive, this one has to be negative. Okay, so these two are opposite reciprocals. Okay, so let's go ahead and try this out on a couple of examples, right? So let's say I gave you the line y equals 2x plus 3. What would be the slope of a line parallel to this line? Well, to find that, I'm going to go up here. I'm going to find the slope. So this one is, the slope is 2. So the slope of a line parallel to that is going to be the same. So the slope is going to be 2 for this one as well. Now the slope of a line perpendicular to this line is going to need to be the opposite reciprocal. So I need to take 2, flip it over. So that's going to give me 1/2. And then I also need to make it the opposite sign. So this one's positive, so I'm going to make this one negative. And that'll do it. Okay, let's try this one. So the slope of a line parallel to this line is going to be the same. What is the slope of this line? Ah, very good. If you remember, there's a 1 in front of that x, so the slope is negative 1. So the slope of a line parallel to that is also going to be negative 1. The slope of a line perpendicular to that, all right, I need to take 1 and flip it over. Well, 1 over 1 is still 1 over 1. And then this one's negative, so this one's going to need to be positive. So this is going to be positive 1 over 1 or positive 1. Okay. Let's try this one. So the slope of a line parallel to this line. So this one's slope is 1/5. So the slope of a line parallel to that's going to be the same, 1/5. The slope of a line perpendicular to that, I'm going to need to take this and flip it over. So 1 over 5 is going to become 5 over 1, which would just be 5. And then this one's positive, so I need to make this one negative. It's a perpendicular slope. Okay. All right, what is the slope of line parallel to this line? So here's my slope. So the slope of a line parallel is just going to be negative 1/3. The slope of a line perpendicular to that, I need to take 1/3 and flip it over. So that's going to be 3 over 1, which is 3. This one's negative, so this one needs to be positive. So I'm just going to leave it like that. So m equals positive 3. All right. So that gives you a little taste of slopes of parallel and perpendicular lines. All right. Here's what you need to do right now. You need to obtain the exit slip. Fill that out. Please make sure it gets to my box. Then you need to obtain the homework. That's the slope of parallel and perpendicular lines worksheet. If you get that done in class, which I think you probably can, go ahead and turn that into my box as well. Okay. And that concludes this lesson. When you're done with all of those things, there is another worksheet. It concentrates more on just writing equations of lines. It's a review from Algebra 1. Go ahead and start on that. Get some ideas down about writing the equations of lines. And when you come back on Monday, that is where we will pick up. All right. So I hope you have a fabulous weekend. Work hard. Make sure that you show me that you understand these concepts. And I will see you on Monday.